Hi, okay, welcome back to our reference table mini videos. This is going to be a quick 5-minute video on reference table C. So as you can see, here's reference table C. I just made it a little bit larger so that when I do my handwriting, it doesn't look like a kindergartner's handwriting. As you can see, I'm in my living room right now. I'm recording these videos. It is now July. I can't wait to meet you all in September. All right, so with reference table C, we're going to use this in the beginning of the year because chemistry is involved in a lot of measurement, right? And our first unit is going to be matter, and how do we measure, and what does chemistry have to do with matter? Well, chemistry is the study of matter, and in order to study matter, we have to quantify it, and anytime you hear the word quant, Q-U-A-N-T, it has to do with numbers. So we're going to be doing a little bit of math, and we're going to be doing something called dimensional analysis. We're going to spend a lot of time in school. So if you don't, get it right away, rewatch the video a few times. Some people pick this up really easy, and other people do not. So we're going to basically use this, and don't mind me, I'm still getting used to this, little, tablet, pen gizmo thing that I've been working with. I'm really, stretching my technology skills since our COVID spring. Okay, so what we're going to be doing is we are going to be doing conversions, right? So wow, I'm really writing all over the place. All right, so we're going to be converting between different metric units. We're not going to be converting between metric and US. You're not going to convert Fahrenheit to Celsius and so on. We're only going to be working with the metric system, which is what we have here in reference table D. Let me scroll down. Right, these are selected metric units, right? So we measure length in meters, grams, and those are our metric units. All right, so let's go down over here. And so in reference table C, what we have is we have our factors. Let me just go over here to the arrow so that I am not writing on the screen. So over here, I've written down a couple things that you're probably going to want to write down in your own reference tables. So we have our prefixes, right? So just like in the English language, the prefix conveys meaning. So kilo means 1,000. Kilo is a big number. So if you're watching, some kind of crime TV show and somebody gets caught, with a kilo of some drug, that's a lot. That's not just a little bit. That's a lot. So a kilogram is 10 to the power 3. So that means 1 times 10 to the power 3. So a scientific notation, right? That means we're going to move the decimal point 3 places. But which way? Left or right? That's always the question. Which way do I move the decimal point? If you have a positive exponent, like this case, the positive 3, we're going to move 3 places to the right. So that means 1,000. So if we look over here, if I'm looking at meters, right? If I'm looking at length, then 1 kilometer or kilometer, tomato, tomato, is equal to 1,000 meters, right? And now liters are measured for volume. If you have a deciliter, right, you have 10 to the minus 1, which means 1 times 10 to the minus 1. So we move our decimal place negative exponent to the left. So let's look at our example problem. So here I have 0.0089 kilograms, and I want to know how much that is in grams, because that's like a really small number, and there's lots of zeros. So when scientists report their information, they want to report it using numbers that are more easy for people to wrap their heads around and to get a mental image of the size of the number. So right now that looks like it's like really, really small, but in actuality, in grams, it might not be as small. So I need to go from the kilograms to grams. So I look over here and I know that 1 kilogram is going to be 10 to the power 3 grams. Okay? So what do I do? So the first thing I'm going to do when I do dimensional analysis is I'm going to write down the number. So 0.0089, and I want to make sure that I use the units, kilogram. And now I want to do a conversion factor, right, which is an equality, a ratio, right? So something is to something else. So then I want to put the kilograms on the bottom, and I want to put the grams on the top, and now I just got to put in the numbers. So I have 10 to the power 3 grams to 1 kilogram. And if you don't like working in scientific notation, you can always make that 10 to the power 3. You can always make that 1,000 because it's the same thing. 1 times 10 to the power 3 is 1,000. All right, so that's our quick little, mini lesson on reference table